Accepted.
Okay, access granted. Nice. I have one task for you. If you'd like to ask questions, you can just scan this code to the Slido, and in the Q&A section, I will try to answer your questions. So you can do it now, and later I will also display this slide. Okay, so let's get started. At the beginning, I'd like to meet Rodrigo. Rodrigo is a software engineer in Latino Latino IT company, and he is working on few projects. Currently, he is front-end developer, but from time to time, he needs to work also as full-stack engineer. And in his company, there was one project, one challenge, because his boss asked him to prepare AI assistants because AI is everywhere. They wanted to create a product, create assistant, and sell this assistant to Latino market. So he started to work on this project a long time ago in March this year. We will see why a long time ago, and what changed during this time, and what will happen soon probably in the web. So currently, if you'd like to build assistant, there is plenty knowledge on the net, but of course you can use just OpenAPI documentation. There is something like Assistant API beta. So currently, we can tell it's stable, but there are a few errors still. And to create a simple AI assistant, and this goal to use OpenAI assistant was to gather company knowledge, put this knowledge to the AI model, and process output in any front-end application. So they decided to use OpenAI assistants. So we have only 4 steps to achieve that. We need to create assistants by code, or just use OpenAPI interface. It may be better and faster because we can tune our master prompt and then just grab ID of our assistant and use it in our code, place this assistant IDs, for example, in CI, whatever. The second step is to create a thread, and inside the thread we are gathering informations. To be more specific, messages are kept inside the thread. So we have a thread, like in the chat. Then we are going to add messages from, for example, user, couple of messages or only one message. And then we need to run our assistant to process this thread. So, okay, step number 1 is quite easy. We need to create this assistant using code, or just use interface from the OpenAI. Quite easy. Second one, we need to create a thread. Also quite easy. To this thread, we need to add messages. So we need thread ID, specify role and content of our input. And the 4th step is quite interesting because we need to run this thread on OpenAI infrastructure. So we'd like to create run with our thread. Our thread contains messages. We need to specify our assistant and some instructions optionally. And what we can do after that, let's take a look. There is a while with an array with 3 statuses, includes our run status, await, new promise, resolve, set timeout, resolve 1 second. It's from the OpenAPI documentation. How do you feel this code? Okay, let's see. And inside the loop, we should check if our run is completed, if we have messages, or what will happen after that. If there is a success, we can process our messages and put, for example, from our backend or from our application to the user interface. So currently, we need to wait in a loop for a response from the thread. So what the heck? What the heck? So probably this code smells, but it was an option from the March. Few things changed during the time. So probably each of you knows the OpenAI interface. So after typing, where's this message? Yeah, we can type anything, and as an input, we are not getting a response from HTTP, right? We have something like an animation, but it's not an animation. This text was streamed to the user, and we'll take care about streaming during this talk. What we can stream, how we can stream, what not to stream. So it can work nice with REST API, but it doesn't work, for example, for real-time interfaces, for real-time user interfaces. And this one small recap, our Latino developer, Rodrigo, started his work a few 4 months ago, and here is his solution. But before, let me introduce myself. My name is Patryk Omiotek. I'm a software engineer, IT trainer, and IT consultant in Web Amigos and Bottega IT Minds. Web Amigos is not placed in Latin America, but in Europe. And there is Rodrigo's solution. So, because the team wasn't big in his organization, and both required to deliver proof of concept, especially to have one single instance together with frontend and with the backend, trying to avoid create new instances of the backend. It was a proof of concept because they wanted to deliver quickly to the Latino market. And in case of the investment in this app, they should scale this application easily and quickly. So let's back to our while loop. So he decided, because this while loop should be run somewhere, for example, on the node. So he decided to run this thread and notify frontend when this run is completed. So we are expecting a message when message to the frontend when message from the assistant is ready. And there are, of course, plenty ways how we can achieve that. And he decided to run thread on the node and notify frontend when this run is completed. So backend is written in simple Node.js, and frontend is managing this communication using React application, but of course it may be Angular, it may be Vue, etc. So we will try to solve this solution, and because he was looking for some way of the communication, and there weren't experts in his organization which can use, for example, queues, which doesn't have knowledge from the Kafka or from the Rabbit, they recommended to use Redis. So probably most of you heard about Redis, but Redis is not quite often used in web applications so far, but maybe it will change because there's this pub/sub mechanism which will be used also in front-end application, and later I will demonstrate, maybe not demonstrate, but maybe I will describe you in which kind of the systems we can also use Redis pub/sub for our behavior. The second idea how we can communicate, of course, popular WebSockets. In the organization, they were discussing to use Redis, PubSub, or maybe WebSockets. This slide will be placed on my LinkedIn, so maybe not go so deep in technical details. You can find them later. And one important thing, they had experts from inside the organization which can just easily scale this Redis, and it is technology, of course, agnostic, because there was second project where this Redis was used. So we as a developers probably are using Redis as in-memory data store, for the cache, as vector database, as document database, but it's also it also fits as streaming engine and message broker. So for this particular project, Redis was enough. It was up and running in the infrastructure, so they decided to use it. And we need to mention about one mechanism. They used fire and forget. So there is no, for example, confirmation that client will receive this message, and messages can be lost during broadcasting. But for this project, it was okay. We were just listening for the latest event or maybe latest event. It was enough for this project. It was set and running and ready to use. So maybe take a look, and we can see, right? One receiver can just stop receiving messages. He or she has information about the last event received, and for this app, it's okay. So let's take a look for the front-end implementation. So we had two mechanisms, Redis PubSub and WebSockets. So probably you can imagine that they combined these technologies together, but not, because they were listening only from the events from the server. So this duplex communication wasn't needed in this project, and they decided just to use simple server send events for achieve their goals. So to recap, what are server send events? Maybe let's talk what server-side events are not. So make this simple comparison. So probably in the life of each developer, there will be this choose to use WebSockets or maybe not. So let's imagine we have a stage, we have an actor on this stage. This actor is our server, and server is sending messages. So for example, EO, and we have a bunch of the clients. There's a client, there's a client, there's a client also here. And clients are trying to send messages. So yeah, we have the duplex communication. So it's WebSocket behavior, and our server-side events are working similarly, but clients are silent. And we don't need these informations from the client to put on the server. And also technical specification. So the most important that we have this full duplex, different protocol, bi-directional communication, binary data support. It's important, of course, depending on your project. Latency and what was important, scalability here, and complexity. In server-side event, complexity is not it's not high. We can just take native API from the browser and use our servers and events. So also there's a comparison to long pooling, but they decided that servers and events fit for this project, for this application. And probably you can wondering what could go wrong. What could go wrong here? They needed to deliver fast on the market. and decided, so maybe we will refactor someday. But you need to remember that there is not such a day like someday, right? So let's take a look to the code. And currently, let's try to simulate similar behavior to have front-end application something like our backend application and PubSub mechanism. Our PubSub mechanism was needed to get this information from this while loop to somehow notify frontend. So while loop was publishing events to Redis PubSub, and our client was listening on these events. So let me switch to the code, and I would like to show you few lines. Okay, mirroring, and I think we have it. Okay. Okay. But before, quick recap about things that we have from the years inside the node. So, for example, we can read our files using, for example, readable stream. So we can create a readable stream and read our file. So let's run our application. Its first example, I don't remember the script, so let me just copy and paste it. Okay, and the role of our file is just to display display content of this file on the screen. So okay, npm run readable stream. Okay, and we have something like that. So we have we received two chunks with the buffer. So automatically our input data was replaced to the chunks. So readable streams are trying to split the data to smaller chunks. We as a people are not able to easily read this content. So for example, we can pass second argument. And inside the second argument, there will be a text, but it won't be easy to find these parts. It's just, I think, lorem ipsum inside. Okay, somewhere it is. Maybe I'm not able to find, but believe me, we have it somewhere. Or maybe I missed. Okay, maybe at the beginning should be this information. Okay, it's a huge file. It's a huge file, and believe me, it's split it on the two chunks. So we have it. And also we can just use two streams, one for read the data and second to write, for example, to the new file the same way. And in the node, we can use pipes, for example, to read informations from our data source, from database, from the files, from Redis, etc., and then process this data somewhere else. And let me show this example. So again, I'm trying to read our data from the input. And what I'm doing with this input is to pass data to HTTP server. So we have response with 200 code, and our content type is text plain. And there is this readable stream, create stream with UTF-8. And line 28, we have readable stream pipe response. So our buffers are piped into the one response. So we can try to run this code. I have it opened on port 3002. No. Where is my browser? Okay. It is somewhere. 32. No. Let's try again. Maybe port was changed. Oh, typo. I forgot to mention that we are going to have demo, and as you can expect during the demo, a lot of things can be broken. And we have our data. And our data was a response to our browser in such way. So I received from the response the first part, and second, and a browser wasn't waiting for the end of the response. It started to rendering our part, and then when additional buffer appeared, browser placed this content, appended this content to our output. Okay, so we have this recap, and we have two additional files. We have publisher, and our publisher. The role of our publisher is just to send a message to our starting to publish messages to particular channel. So our channel is just session 1 to 3, very original. So let's try this one. So I have subscriber up and running and our publisher. So we can observe. Let's stop publish subscriber, clear the console to make sure that everything is working correctly. Okay. I'm listening to 2 channels. Let's try to run publisher. Publisher is trying to send a message. And okay, we received this message. So currently publisher is pushing data inside this PubSub mechanism and subscriber is listening. But we have our subscriber in the node. So let's try to port our solution to the browser for the usage of response from the assistant. So let's go to second application, and our second application it's maybe bit complex. Rodrigo forgot that they don't have budget for the backend application. So the first thing he delivered was a Nest.js application with session controller, and this session controller has built-in servers and events management. So he decided to create, to use server-side event decorator, and for example, on the session ID SSE, he's trying to fetch session ID, and from event emitter, which is listening on the messages, from our mechanism below, we are just returning this message. And he made backdoors to send these messages to the browser. So we can just use webhooks, and these webhooks will run a session service to emit this event. So frontend will be able to receive this connection. So on the frontend side, so we have backend, we have our publisher, and on the frontend side, we'd like to somehow receive our events. So goal of this application was to somehow receive events, and our developer decided to use React this time, and decided to use this endpoint so we can observe how it's working, if it's working. Yeah, it should. So maybe let's check inside some tool like Postman, SSE. Okay, send. Okay, we are connected to session 1 to 3, and we can observe, of course, that we don't have a constant response. We don't have a JSON. We just created connection to our endpoint, which Rodrigo delivered. And let's use this backdoor. Let's call our webhook endpoint, and place some data, for example, with this JSON type, hello message, payload, ID, and content. Let's send it. We have status 2 or 1. Looks good. But inside our stream, we can observe that we have this message. So okay, connection is up. Everything is working correctly. I will try to click few more times to simulate this behavior. And yeah, we have this second message. So great success. Maybe we'll try to use our front-end application to combine this solution. And front-end application, we don't have to focus that it's React. It may be implemented the same way, of course, in a similar way, in Angular or in the Vue. The thing that we need to achieve if we have this endpoint is to make a connection. So for example, we can use event source, and it's quite important that there is this new event source object. Event source is built in the browsers. So we don't have to install anything. We need to pass URL for our endpoint. Then we can receive our messages using, for example, event listener on our event source on the message. So our message is just a plain text. So we can parse our message and, for example, populate state with this message. And in the React case, we can use effect and remember to close our event source when it's not needed anymore. Or for example, we can add additional error handling. So for example, we lose the connection. Then we need to decide if we want to connect again, because in some scenarios, this kind of the endpoint is used, for example, to receive few events, and then these events are not needed anymore. So we can just grab the fresh ones. And let's see our beautiful user interface. Our interface is not running so far. So let's open and 302. I think we have conflict with previous application. Okay, 302. And there is our beautiful front-end application. Let's take a look to the network tab. Okay, we have server-side event with tab event stream. Nothing is here, so let's try to publish our message to the publisher, and we will check if our mechanism is working. So again, we are using this backdoor, and twice I send it twice this message, and inside we have our text. So we have our text, and a great success. So we can use this code and go to the production. So Rodrigo demonstrated his solution, and they decided, sorry, we have this front-end and back-end. We agreed only on one instance, and we need to somehow remove our Nest.js application. So he tried how to keep things inside one application. Fortunately, we have something like Next.js. In 2024, people have started to name Next.js as full-stack framework because we have this support for the backend, we have this support for the frontend. There's also hydration, but for the deployment for one instance somewhere, it might be good enough. So let's refactor our application and back to the code, to the component, so our component with the name messages we'll use different endpoint. Um, different endpoint, yes, on the same port. So our API, SSE, is using internal API. So we have API, SSE, and it was created by Rodrigo from scratch. So he decided that we need to use some kind of the source. So this kind of the source should have proper headers. And these proper headers, if you need to implement server-side events in your applications, is to just make sure that content type is set to text event stream with proper encoding to keep our connection alive, and not to cache our response, not to transform. Okay. Then, for example, we can use we can create custom readable. This custom readable is used as a response. So we are responding not using JSON, for example, not using text. We are responding using custom readable, and our custom readable is a stream of the text. So, for example, implementation of this readable stream may be different, of course, in your purposes. But let's try to create controller, and our controller is sending initial message. So, for example, with type init, with some payload, and here we have our controller enqueue. So we are adding messages to the queue, and we have encoder encode because our code should be replaced to these bytes. Okay, so from the text we are replacing into the bytes, and the browser on the front-end side will read these bytes and parse to the text, and this text we will replace to the JSON. And currently we are in the scope of, let's say, backend part. So we have an access to native Node.js API. So we, for example, can use our publisher mechanism. Of course, here we can use Kafka, we can use RabbitMQ or any different mechanism. So we are trying to subscribe on the changes in the line 28. And if there is a message, and this message is with the same ID like the channel we are listening, so we are adding this message to our servers and endpoint queue. So let's restart our application, and again we have our endpoint with initial message. Let's try to publish information on the same mechanism, on the same PubSub. So our from our publisher, or from just our backdoor. Can I use backdoor? Backdoor was using this backend written in Nest.js, so it won't work anymore. So we can need to use this native, let's say, native communication. So from the different part of our architecture, I can publish messages, and our messages are on the front end. Let's publish it again. Okay, I have the second message. So we replace our whole backend application with native communication with Node.js PubSub with Redis, and it's just Next.js application this time, React on the front, and on the backend it uses its own APIs. Okay, so we achieved something like that. Let me change screen mirroring. Okay, so we achieved something like that. Okay, but this version was good enough. So they delivered this proof of concept. Customers were interested in further cooperation, but few weeks ago, after this deployment, in March or in April, if I remember correctly, OpenAPI for this assistance API created the option to use streaming without using this ugly while-true loop. So currently, we can use streaming with our API instead of while-true. So currently, we can just use, for example, create and stream methods, and there is plenty events that we can attach and can listen to get data. And reaction of the team was devastated, right? Because they trying to omit this white loop, and currently the life is much easier than in the March. So, for example, we can just attach, for example, on the thread created, message processed, or we have delta of our message. There's a lot of possibilities, and maybe not in this slide. In this slide, we have the table of available events. So instead of using this this loop, we can just listen what is needed for us. So yeah, only a couple months ago there was different approach, but at the same time, this native communication with publisher and subscriber maybe can be used in different type of the project, and also on this organization one project appeared. So they needed to communicate to deliver mobile application or front-end application, also for example with the React, but the source of the event was a video game in the Unity. So Unity used this PubSub mechanism to throw somewhere these events, for example, to the backend, and the front-end application was listening on the events from server-side events using this PubSub mechanism. And it is only my opinion on the next slide, but let's consider what if OpenAI will promote server-side event for web apps. They started to use server-side events. Server-side events are not something new. They exist in the browser for a lot of years. But currently on the page of the OpenAI, you will find a recommendation that server-side events will help you build assistants. And today, a lot of application is created each day using OpenAPI. So maybe there will be a hype for that. But of course, in your project, consider, of course, each possibility, to consider WebSockets, to consider let's say long pooling, to consider streaming for that. Okay, we had demo before, and what we can stream in our applications. I was talking only about server-side events, but we can stream a lot of things on the web. So for example, videos and audio, live events like sport matches, concerts, conferences, webinars. There is real-time communication. We have chats, video conferencing, data feeds, for example, financial data, market updates, etc. Progressive loading for loading huge images, for loading huge files. Also for the file transfers. If you'd like to put huge file, it's not sent in one, for example, request. It's splitted for the bytes, and bytes are sent using the streaming somewhere in the net. We have server-side events, we have WebSockets, and one thing that I'd like to mention, this partial prerendering may be something that partial prerendering is using streaming. It's something new that is promoted to be the next thing that will be used in during building web applications. So partial pre-rendering currently in Next.js, currently, but it will be adapted in different frameworks. So, for example, in Astro, and similar solution. And our partial pre-rendering is a feature that allows static portions of a route to be pre-rendered and served from the cache, for example, and dynamic hosts, which can be, for example, it may be an island or maybe React components, will be streamed, but all in the single HTTP request. Instead of fetching, for example, for the data from our components, let's say we have one application shell and we have 5 components. In component currently is trying to fetch the data, so we have 5 requests. Using partial pre-rendering, we can use HTTP streaming with HTML, and we will get one request that will try to render our application, and then this response will be appended to our result. So creators of Next.js made some trade-offs because there is traditional server-side rendering and incremental. So we will focus on that. So they trying to make a solution that will that can be used, so for example, to make this application shell and place our dynamic components somewhere in the application. So it's a combination. Let's say it's a combination of incremental static regeneration from Jamstack, from the Jamstack where we are creating our application, the whole application, and deploying somewhere on the server, plus a combination with server-side rendering. So for each request, so for example, server is rendering the response. So it's a response, it's a solution, it's a try to connect these two mechanisms together. And the usage, for example, of suspense in React may be this boundary where we can decide whenever the boundary is static or dynamic. So we as a developers, maybe in this year, if not in the next year, I think without huge effort, we can deliver that kind of on the applications. And our applications, so for example, we have page application, there is plenty HTML elements, and there is a shopping cart and recommendations wrapped by suspense with skeleton. And there we have this boundary. So application shell will render on the server everything instead of our shopping cart and recommendations. So on our application shell, there will be skeleton and skeleton list. It will be returned to the browser, and after that, in the same response, our shopping cart and recommendation will be placed. So during build time, suspense will wrapper our components, and suspense will allow us to fetch data in parallel, and streaming lets you replace the suspense component with the fully rendered bits as each of them finish. But everything is done on the request time. So one demo, last demo from the creators of Next.js. Let me switch the screen. Okay, we have it. Yes, we have it. So let's open DevTools and inspect that. Let's open Network tab, and I'd like you to observe two places of this application. The first one is this get in June, and second one is the list of products. So it's the first part and it's the second part. Let's refresh this page. We are on the Fetch tab. So we can observe that these parts of the applications are loaded after our shell, but inside Fetch there's nothing, right? It was returned using our previous response. So our response was opened, and then data were returned. And okay, so we can go to the conclusion. In web applications, streaming is not something new, but currently there are a lot of possibilities that we can use. Streaming, for example, to provide this functionality from the Jamstack and from the server-side rendering, to have faster applications, to have better applications, to provide better user experience, and of course to create more elegant solutions. So with this concern, I'd like to leave you, but I have one question. There is this application we are using during Devoxx. How do you think? Is it using server-side event, WebSockets, or something else? Because we have this live updates. No? No? Okay, I will leave it with you. I think we don't have much time for the questions, so maybe I will just take a look if there are any. Okay, login. No, we didn't have. No, we don't have. Okay, so thank you for your attention. Have a tasty dinner, and see you. If you would like to ask questions about the streaming, pre-rendering, server-side events, you can find me on LinkedIn. And on the LinkedIn, I will place slides, I think, this week or maybe that week. So thanks for your attention.